This is kind of a cool question. It's very conceptual in certain ways, but I don't think it's that hard. A cylindrical can containing pieces of fruit is filled to the top with syrup before being sealed, so liquid. But the fruit is solid. The base of the can has an area of 75 centimeters squared, and the height of the can is 10 centimeters. If 110 centimeters cubed of syrup is needed to fill the can to the top, which of the following is closest to the total volume of the pieces of fruit in the can? It doesn't feel like it, but this is a shaded region problem. We normally see those with area, but they found a way to do it with volume. So first of all, it's a cylinder, so we're going to be here. And the first thing I notice is when they say the base of the can is an area of 75 centimeters squared, like already for volume, you might be thinking, well, volume is pi r squared h. It says it right there for the cylinder. We have the height as 10. We do not have the total volume, right, of the can. So that's a problem because then do we have the radius, right? So, I've got to solve for it. And we know the base of the can is a circle. So I'm just going to solve for the radius. I'm going to say, okay, this circle here is going to be, what did they say? I'm already forgetting. 75, right? So 75, that's a circle. So that's equal to pi r squared. Let's divide by pi. Let's get the radius. No. Look, the area of a circle is pi r squared. Look at what's in the formula for the cylinder. It's basically the whole cylinder formula comes down to the area of that circle times the height. So rather than get the radius, we already have what we need. This pi r squared piece is the 75. We're just multiplying that by the height. So rather than deal with an individual radius, let's get rid of all of this. So just to be really clear, this corresponds to this. So that's what's going to pop in there. So now very quickly, we have the volume. The volume is 750. And it's composed of two things, right? It's composed of these little pieces of fruit that we don't know anything about. We don't know what shape they are. We don't know, how big they are. It's just there's fruit in there. But in between all the pieces of fruit, right, if we think about the can kind of looking like this, right? So these little fruit globules in there, right? They're kind of smushed together. But there's these little pockets of space between, right? Because they're not, perfectly smushed in. There's space between them, like little rocks in a box or something, right? There's air. So we need to fill that air, and that's where the syrup is going to fill in all that space, right? So the syrup is going to come. It's going to fill in all these little crevices. So that syrup is 110 centimeters cubed. So we just have to subtract that out, and whatever's left over is however much those fruit pieces take up. So that's pretty easy subtraction, 640, and that's our answer. So it's a cool question because it's basically just the formula for a cylinder, but they asked it in a way that you really have to understand, you got to picture things in your mind, I guess, in order to be able to do it. But this kind of idea of a shaded region, shaded area is maybe what we normally think of it as. That is a common SAT tactic, is to make you think about this unusual shape, this weird shape, by working with other familiar shapes around it. So doing subtraction and an addition to get the weird piece. Usually, though, it's on a flat two-dimensional surface. This one is 3 dimensions, but it's the same idea. But really, if there's one thing to take away, I think it's just remember that the formula for the cylinder is the area of the circular base. That's why the pi r squared is in the formula. Pi r squared is the area of a circle, and it's in the formula because you're just getting that area and then you're multiplying it by the height. So that's pretty convenient, and I do think that they designed this question to reward people who made that connection. And yes, you could get it by finding the radius and then multiplying it back in, but that's wasted time. So the SAT definitely designs questions sometimes that are, gettable if you just kind of go a very traditional path. But you can save 30 seconds or a minute by just realizing like one cool thing. There you go. Hopefully, if it comes up again, you've got that one cool thing.